returned. uh, and looking at the situation here, right? So we're trying to pass the message that we're getting from rate limit error. But why? What if I did like for the solution that we're intending to do, we don't actually need to know any of the details from rate limit error, which is fair because it's just a string apparently. Maybe that's actually JSON. I don't know. But what we can do is, what we should do, actually, let me check something really quick. So, I didn't think so. Okay. So, as I've gotten a little bit more practice at implementing Lambda functions in Rust, I've kind of accumulated some things that I want to have happen. And one of those is setting up tracing subscriber for tracing / logging. We probably need to add that to the cargo.toml. Add these two things. So let's do that. Yep. There we go. But the point of mentioning that is what we can do is we may not necessarily pass all the details of the error back to our caller, but we can definitely, tracing, maybe not an error, maybe a warn, like so. There we go. Tutia says, I really love how you explain stuff even though I don't understand coding, but I'm really interested about it. Well, I'm happy to field questions, and I'll try my best. I tend to verbalize a lot when I'm coding, just because it really helps me. It helps me. It's great if it can help you, or maybe even just entertain you. But it does help me kind of make sure that I'm thinking through things. Can we? Let's see. Can we do something like this and then add tracing like that? Yeah. And then now the function is too long. Yeah, that's what it is. I knew as soon as like everything went yellow that's what it was going to be. It's the Rust analyzer or Clippy saying the function has too many lines. I probably should see if we can extract out some things. We could probably extract out result. Okay, so I can probably. Are we using result anywhere else? Yeah, we're using it there. Okay, so I can probably extract out this at least. Refactor, extract into a function. Sure. And then we can use Copilot to rename or suggest a name. Update transcription summary. Sure. And that gives us. Well, it's going to give us a result. Is what I want here. So I'm going to say something like that. Right. So now we have to say what the type is that we're returning. Sure. So we need to turn we want to do this. We want to turn the error into an error response. Copilot's got that for us as well. What's the problem now? found unit type. Oh, right. So if it's successful, we need to return OK with the unit type. Cannot move. I mean, really, it should just be like input key. ToString. Good with that? Okay, and then we just have to update where we're calling this to pass in an input key. Okay. Oh, and then we want to do this. Right, so question mark. Yeah, so that unpacks our result. And either it's okay, in which case, well, we don't save that anywhere, so it doesn't matter, or it's an error, in which case it returns out of the function and returns the error. And that also stops us from having too many lines of code. This is complaining because Clippy is like, you should use map or else instead of an if else. So what would that look like? Actually, before we do that, so right now we're explicitly panicking if we don't get the right thing. So instead, what we want to do is we want to return something like that. Yeah. Oh, and it's too long again. What is gonna make sense here? Let's I guess we'll just extract this into a function. Yeah, that seems fine. And then rename it. Fetch OpenAI secret. Seems good. Now it's not too long anymore. You're still not happy about this block of code? The match can be collapsed into an outer match. Yep. Fill match arms. No, that's not what I wanted to do. So, oh, I see. Right, so this can be here, in which case this should be text. And then this can be some anything else, which matches to this. And then get rid of that. Okay. Match arm has identical body, right? So both of these do. So really what I can say is, if it's not some text content, then do that. All right. Oh yeah, and we want to invalid response. Yeah. And then it's like, hey, this match can be collapsed into the outer match. That's right, because these arms are the same. So right. If we just replace that. How does this work? Do we do that? Okay, well that works. Well, that is a lot simpler than what I had before. I think it does the same thing, and then Clippy is like, hey, this could be a let else. So I think it will auto do that for me. Nope, never mind. Yeah, because there's just like the two branches, right? So if we say, how would we do this? Oh, it has an example. So we just have this part of the this arm of the match immediately after let equal to choice.message else this thing. So I'll just copy this. Often that's an option here, and it automatically does it. I guess in this case it didn't. So maybe there should be a comma there. Yeah, there we go. Okay. So if we can unpack choice.message and it matches this structure, we can set set text to be that. So is that what we lost here? Is that now this should be text to work? Yeah. Okay. So our assumption is that when we do the transcription, we're going to get a message back from the assistant, and it's going to have some content, and it's going to be text. So if that is all true, then we run with it. And that's what the existing code was doing. We've just condensed down. What was it before? We like roll back. Let's see, that's too far. To here, right? So we condensed down all of this into this. It's not bad. So anyway, more broadly, what we're trying to do is we're trying to get rid of all the places where we're using expect. So we'll just keep on doing that so that the Lambda won't panic anymore. And Copilot's pretty nice in terms of seeing the pattern and following it. So if we do expect, I'm fine with panics inside of main, right? So this is with the Lambda function, you have a container essentially that gets run when the Lambda is invoked. And then what happens is that it runs the whatever executable runtime. In this case, for our Lambda function, it's this main function that gets executed when the Lambda is booted. And then what will happen is that the Lambda runtime here listens for requests. Like it's like a mini HTTP server. Is that how I think it works? And then what will happen is if that container is around, or rather, if after you make your first request, your first Lambda invocation, that container gets spun up, it's running, the payload, the event gets sent to the Lambda, and then AWS will keep that container running for a little bit of time, and then will eventually, if there aren't any requests, it will tear it down and it will go away. But if you make another invocation of the Lambda after the first one, and that container is still there, it's still warm, then the or rather, the existence of the container still being there makes the Lambda warm, right? Versus cold if the container isn't booted up and running. So if that container is there, it can send the next event to the same thing. And so all of this stuff is already run. Like we already have loaded the config, and we have the AWS SDK and the DynamoDB clients and all that stuff. And then all gets reused, and it's just the handler that gets run. There are caveats to that. So that container does not handle concurrent requests. So if one request is going and another request comes in, another container gets booted up and gets cold started and runs all of this. And hey, Coffee and Crocs, thanks for the follow.
Coffee and Crocs just followed.
Welcome in. It's a nice name. I like it. I'm unfortunate. I got through my coffee already, and I'm just in socks, so no Crocs for me. Okay, so anyway, I think it's fine if the Lambda panics like when we're booting it up. That's like that shouldn't happen. And there isn't really, I guess we can return an error here. I guess we could do that. We could, like, or else do, yeah, we could do this. Except error response is not right. We would actually have to give it, I don't know, could we? Could we use the same error response here? Does that work? No, because the Lambda runtime run gives this kind of error. Okay, so let's not. Then I guess there's not a point in not panicking. Okay, so I think that's the only expecto is right there. If we basically, this is checking because this is our function load config that uses Figment to load environment variables. What's this about? Unnecessary structure name repetition. Yeah, that's gonna be self. Right? Self. Yeah. Oh, and this can also be self. Yeah. This function has too many lines. That's true. It's feeling very lazy in terms of rebuilding the hash map for setting the thing in DynamoDB, but that's fine. That's just how it is. So what else? One thing I'd like to do while I'm here is that let's see. So summarize transcription. So we today in our Pulumi code, which I have been seriously considering switching from Pulumi back to the AWS Cloud Development Kit, but I haven't gotten around to that yet. I think what I'd like to do is do what I'm doing on the other Lambda functions, where I have an ECR repo and I have the Lambdas be Dockerized, and then I can push a Docker image to Elastic Container Repository. That's what the ECR stands for. And then the Lambda will use that. And that way things will be consistent, and I can use my little task that I made to deploy Lambdas without even having to do anything with Pulumi. So let me go find an example of how that's set up, and we will reproduce that example here. I think this might be the last Lambda that is kind of using this approach, where it's just using a binary that's compiled locally and uploading it. So yeah. So in stream ingestion, are we making any other Lambda functions here? Summarize transcription is the only one, right? Okay, so we'll just make whatever. I'll call it summarize transcription repository. And summarize transcription repository, and repository name summarize transcription, scan on push. All of that's fine, and then we want that image tag. with the appropriate name. Grab that. Okay. And then actually this is not even for a Lambda. Let's go find where do I have where do I have a Lambda? Oh, an API? Yeah. ECR. There we go. So, code goes away. Handler goes away. Runtime isn't relevant. Package type is image. Image URI is the tag. And then we have tracing config. I started doing logging config as well. Put that in there. And I don't think we have to change anything with the role. Like the Lambda role doesn't need to interact with... I don't think it does anyway with ECR. Does this role have... I mean, presumably we set up the role to have X-ray. Although we can do it in a nicer way by using the managed policy ARN. So that has the X-ray permissions baked into it so that it can like do X-ray application traces without needing that policy explicitly set. Okay, and then the fun thing about this is not going to work first time. It's going to create the ECR repo, and then it's not going to be able to update the Lambda because there's nothing in the repo. So this will be like a multi-phase thing. So let's start that. We haven't deployed anything to AWS today, so let's do that. Pulumi up. Let's see what we break. Okay, so this is going to update the existing role because we changed the thing to add the manage policy. It's going to create the repo. Then it's going to try to replace the Lambda function. That's not going to succeed because the repository doesn't have any images in it. And then it's going to update some other stuff. It's going to... what happens here? I must have... Oh yeah, did I add stuff to the step function? I don't think we've changed the step function. I might have changed something in the step function since the last deploy. Okay, well let's just say yes. Really, what's the oops? What's the worst thing that can happen? And so I already know this is going to fail, so we'll wait until it fails, and then we'll start working on Dockerizing our Lambda, which should be really straightforward because we already have a good Docker image that's derived from an image very long ago supplied by the one and only Brainless Society, who is, as of today, 13 months, a sub here. But yeah, so you can see source image does not exist. Yeah, so let's fix that. So here's the Lambda. We have another Lambda, actually a couple now, that have this Docker file. So I'll just copy it. I'll paste it over here. I could just use one Docker file, couldn't I? Yes and no. So one of the Lambda functions needs other dependencies. What I probably want to do is I want to do something where I have like a common base image or something. I don't know. This is fine. I'll just copy paste. Transcription. All right. So this is just using the Rust base image. It's by default using the latest version. And then we use cargo chef to cache dependencies. And so we have some stages here that do that. This structure is ultimately what came from Brainless. And then we make a final image. In this case, I'm just using the Rust base image again. And then I'm just copying the compiled release version of the executable to the root directory as bootstrap, because this does actually have a Lambda runtime baked into the executable. That's what our main function is and does. So one thing I need to know is I need to know the ARN of the repo. And so we know that because it was in the error message. It's right here. And I have a push lambda.sh. And it's kind of, it's not the fanciest thing ever, but it works. What is my... Hold on. What is it called? Summarize transcription. Function name is not set yet. ECR repository is hold on, something. Wait, I'm confused. Oh, we actually gave it a name. Maybe I didn't give a name to the other ones, and so they just generated names. Let's see if this works. So I have the Docker file. We didn't have any errors from Clippy or anything when we were editing the Rust file. We updated cargo.toml. We have the ECR repository listed here. We have this set. So I should be able to do run task, deploy Lambda. Oh, one more thing, tasks.json. Excuse me. I have a input in my VS Code tasks.json. And so this lets me pick. And I guess, yeah, it's just called summarize transcription. The other ones are like something Lambda, but yeah, anyway. Okay, so run task, deploy Lambda, summarize transcription, and I did something wrong. Oh yeah, it's supposed to end, yeah, it's supposed to have 2 semicolons because shell script magic. All right, so run thing, summarize transcription. Oh, I don't have Docker running. One moment. All right. It is a running. Let's do this again. Deploy Lambda, summarize transcription. Okay. Yeah, I get tired of like doing this manually. So besides it doing some things and knowing like details of the ECR repositories, the main thing this does is it figures out this stuff, and it runs like the ECR login stuff with Docker login. It does the build with the right tag, and then it pushes the ECR, and then it triggers an update of the function. We don't have the name of the function yet. But yeah, there we go. So we're building our Lambda as a Docker image. And the main thing this is going to let us do, the whole point of this, was that our Lambda will now return errors that have like details about what went wrong. I guess what I can do for testing purposes is that we can start off. Let me go find. Here we go. Here's a rate limit error. We're going to break the Lambda. We'll have to wait for this to do, and we'll redo it, I guess. Actually, no, this should be fine, right? Because it's going to get to the build stage, and then yeah, I think once we get through all the dependencies, it will actually use this version that I've just what I've just done here. So we're going to make it so the Lambda is always going to return a rate limit error, and then we're going to see what that does inside of the step function. And then we're going to be able to update the step function to do something different when it gets a rate limit error. Which is way easier than, I don't know, trying to provoke a rate limit error. And then, yeah, all that. It's much easier just to fake it. Or to force it. Or to force a fake. All right, that's going to take a minute. So let's take a look at this code, this JSON representing the step function. So basically, the structure of this is that there's some stuff you can do. The main thing is start at that says, hey, there's a key string that represents the state to start at, and then you have a states object that has a bunch of different keys and values. Each value describes some state, and there are different types. So a past state doesn't do anything, but you can set or manipulate state values in it. So this setup state just like sets these parameters, and this becomes the state of the step function. So one of the things the main thing I'm doing here is I'm saying this step function, when it's invoked, is going to have some parameters. They're going to be initial prompt, initial summary, and stream ID. So those are things coming from the API gateway when it's starting the step function. It checks to see that those are there, and then it runs the step function. So we're pulling those values and we're dropping them inside of this structure. We're also setting up this iterator object with the index of 0, indicating that, hey, we're going to be looping over something. It'll be the list of videos. And we're going to start with 0, and we're going to increment the iterator as we process things. And then, yeah, so we get stream from DynamoDB. We get the list of video objects by enumerating them from S3. We pull out the count of results, and we get the results. Otherwise, pass everything else through as is. We loop over the video. So here's where we're like, hey, is the iterator index less than the count of videos? And then if it is, then we get the next item from DynamoDB, and we proceed. And this is just like a chain of things to do. So where we want to change things is when we get to summarize transcription, right? This is where it invokes our Lambda, summarize transcription Lambda. And here we actually do have some error handling already. We're saying, hey, if the error equals any of these things, we want you to do exponential backoff. We want you to attempt a max of 3 times and start with an interval of 1 second, I think is what this is doing. So what we should be able to do is just add another block here where it's like error equals our error, rate limit error, and do some stuff. I'll probably have to go look at the docs. Let's see, step function, error retries. to retry. Here we go. Handling errors, step function workflows. All states except for pass and wait can encounter runtime errors. It's focus mode. Interesting. But you have a focus mode, but you don't have a you don't have a dark mode, huh? Okay. So here's like all the different errors that can be caused by what's happening inside the step function. There we go. Retry. Check error equals. That's what we're doing here. You can set interval, max attempts backoff rate, the multiplier by which the retry interval denoted by interval seconds increases after each retry attempt. By default, it's 2. Jitter strategy exists, so we can add exponential backoff with jitter. This is a hallucination. I think it's supposed to be just full. I guess you know what'd be really cool? Is there a JSON schema for step functions? I don't know that I'm gonna just randomly take, and also it's from 2 years ago. It would be nice if there was a thing, but anyway. Okay, we were waiting for a couple of things. One was, yes, so we built the image. So that's gonna let us go back to Pulumi and deploy again. It'll be able to update the Lambda. Actually, it's not going to be able to. We have to change the name of the Lambda, I think, because why? Because I don't think you can change the package type. So before we had a local binary, and what Pulumi was doing was that it was packaging up a zip file and uploading it. So you can't change the package type. So this is gonna fail. We'll try it anyway since we're here. Or I could be wrong. Oh, hey, look, creating replacement. So I guess it recognizes that it needs to delete the existing one and create a new one. Okay. Well, then I'll go back to here. I could have sworn, I don't know, I must have done something differently, but I definitely changed a Lambda and it didn't try to create a replacement. Well, whatever. Okay, so it replaced it. That's good. That's probably why this role is being changed, because the ARN of the Lambda potentially could have changed. I guess is the logic there. I need to know what the ARN of the Lambda is. So we're going to go back to here. We're going to go to AWS. We're going to go to our Lambda functions. And we have this Lambda. We're going to go to our shell script. We're going to put that in our function. And I don't need to redeploy. So when we did this replace, it would have grabbed the latest image anyway. So we should be good-ish now, unless we wanted to really just see the script run, but it should work. Should be fine. So like if we go here and we go to test and can we just send this any old event? Okay, excellent. So we get a deserialization error. We need input key. Actually, we probably need a couple of things here, but definitely input key. Do I want to just keep on repeatedly testing until I find all the things that are missing? Oh, that's not valid JSON. Yep. Correct. Interesting. I think that maybe we did not use this version, and I was wrong about what it was going to do when it was building. So let's redo the thing, and we'll rebuild the image. Yeah, because it's still running. Kind of weird. What would it be doing? From attribute value. So transcription is supposed to be an object for one thing. That's fun. Yeah, I know I need double quotes around the key. Huh. That's really weird. Quite strange. Let's go to CloudWatch. It might be a new log group now. Yeah. Log groups. Filter, AWS, Lambda. This one. 860. Yeah.
Mission complete.
There we go. Yeah.
Mission complete.
I think this is a lie. Alright, let's send a different test event. Okay, failed. Expect exactly one key in the object, found none. Right. Okay, so what is the test? What is an appropriate test thing? So this needs to be an attribute value. But more specifically, for this to work, when we parse this, we're expecting to get, I guess it doesn't matter as long as it's a valid, like, DynamoDB attribute value, so that should work. Do it. Okay, there we go. Okay, so it definitely built an image that had the version of the source before. Interesting. I set the function name. Well, I want to rerun the thing, so what we can do really simply, so we go over to image, you can click deploy new image, and then it already has like the latest tag, so all I have to do is hit save, and we'll get a little thing up here saying it's updating the function. And we'll want to wait until that's done. Now, I have it set up an API gateway where it runs this function. This function doesn't have versions, right? There's no versions here. It's just the Lambda as it is, which is now updated. So if I were invoking this Lambda through the API gateway, as soon as that the pop-up there said it was done, that would immediately affect the API, which may or may not be what you want. You might want to have version lambdas or versions or stages or whatever in API gateway. Lots of things you can do there. Let's go back to our test. So we have our test event. So this should provoke our fake rate limit error. There we go. Error type rate limit error. So what that should mean is that if I were to, let's think about how we can test this. Let's go up here. So here is an example of the input to executing this step function, stream ingestion step function. So we have some like input data and we have a stream ID. And what this is going to do, it's going to do some stuff. It's going to identify the objects in S3. I kind of already walked through all this, but basically it will get to the point. It shouldn't do any of these things because these already happened. But if we were to rerun this, it would hit summarize transcription. And what I would expect to happen with the existing step function is that it will fail and just bail out because it's not a handle. The error type that we're getting from the Lambda is not handled anymore. So if I were to say, hey, new execution from here, it's going to give me this input. And let's start. And what I'm expecting is that it's going to get through. It's going to go straight through to here, and this is going to fail. There we go. Caught error. And we did some retries apparently. Oh, because this state machine is not authorized to invoke this Lambda. That's weird. It's kind of odd. This is something 6102. It has this role. Maybe somehow the role didn't get updated. Did we finish the deploy? Or did it? Yeah. And it updated the role on the state machine. So here's that. And it's allowed to revoke 860 latest. It's kind of odd. Let's just try again. Let's start a new execution and use the same input. Okay. Interesting. So the issue here is that, yeah, this is referring to a Lambda that doesn't exist anymore. 1F3676A. So something in our code is not telling, like our Pulumi setup is not telling it that the step function is dependent on that Lambda. So when it recreated it, it should have redeployed the step function. Also, if we're gonna be testing this, yeah, we can do that. Let's just test it all. So when we deploy the step function, like the role is obviously dependent on the Lambda. So the role has the right ARN, but the step function, while it refers to it, this implementation must not understand the idea that that makes it dependent on this. Yeah. So how do we add a dependency? Is it something inside of resource ops? Yeah. There we go. We need at least that. Let's try that. And if we redeploy now, is it going to try to redeploy the step function? Well, it maybe should anyway, because the string changed. So I guess this is maybe not an effective test that in fact it is respecting the dependencies. But whatever. Like I said, earlier in the stream, way earlier in the stream, I've been thinking repeatedly about how much I miss the cloud development kit as I've been using Pulumi. And since I have no cares about like cross-cloud, multi-cloud, or any of that stuff, not that AWS is like the only thing out there or the only thing I would want to use, but it is the only thing I want to use for this project. So I think though I should be able to click new execution now, and we can. This should fail for a different reason. There we go. So task failed. Why did it fail? Rate limit exceeded. Rate limit reached. Rate limit error. And you can see that we did retries. We did do retries here, which if we did not have this new thing, we wouldn't have. So what if we change this to be like interval seconds is 10 seconds, max attempts is 4, backoff rate is 3. So like its escalation of like how long it waits will go up much faster at the cube instead of the square. And so that should be much easier to see in the behavior of the step function. Let's try that. And then we're gonna need to find someone to raid here pretty soon. So I need to get some lunch. But we can at least see this through, I think, before then. So if we go back to new execution, we should get to summarize transcription. We should be able to see it down here too in the table, right? So we have task failed because of rate limit error, and then it waited 8 seconds and tried and failed. So what would we expect here? Well, it should have been 10 seconds, but you know, there's jitter, right? So plus or minus some amount of time. And then it's going to try a total of 4 times. It's been twice so far. 10 cubed is a long period of time. Yeah, so it went from 8 seconds and waited another 20 something seconds. So that's 3 failures. It's going to try one more time, I think. Except it's going to be much longer. Right? We went from 8 seconds to 20 something seconds, and now it's going to be like several minutes, right? Anyway, I think that demonstrates that we are responding to the error, matching the error that we're returning from the Lambda, and that we are employing jitter and exponential backoff, which was the whole point of the task that we set off to do. And hey, that makes 2 tasks. Plus some fixes at the beginning for the stream today. So I will try to get that all committed and pushed up and merged in here after lunch probably. But for now, let's go find